This is a video on section 8.5, which has to do with functions of angles and identities for Math 175, pre-calculus. First off, let's talk about if we had a given right triangle. So we'll say given a right triangle. And I'll make an x and y axis. So here's x, here's y. And we've got some angle here we'll call theta, and this will be a right triangle here. So this goes out to a point, and this will be a right triangle I created in the first quadrant. Once I have that, I'm going to label the sides. So this side has a length of x, right? The distance from here to any point over here is a length of x. And the distance for this height, right, to this point is a height of y. Right, because really the distance on the y-axis going up to the y-coordinate of that point. And we'll say that this hypotenuse here we'll call r. This is like the radius. When we did the unit circle, this radius would be 1. But if this is something larger, this radius can vary. Alright, and a couple things to note. Because of the Pythagorean theorem, we can note that x squared plus y squared is equal to r squared. So from that, we can say that we know r is equal to the square root of x squared plus y squared. Alright, so r equals x squared plus y squared. And we're going to say r is greater than 0 because of the distance. Right, but we should know this. R is equal to x squared plus y squared. Go on to the next page here. We're going to use this to help us evaluate trig functions. Alright, so for trig functions, we'll say let the point x comma y be a point other than the origin on the terminal side of an angle theta. In standard position. Alright, the distance from that point to the origin is r equals the square root of x squared plus y squared. It's actually what we just said on the previous page, right? If I go back a page here just for a second, right? This point here had coordinates x comma y, right? X was the distance on the x-axis, y is the distance on the y-axis, so the coordinates are x comma y. So the length of this hypotenuse r, as we found below, was r equals the square root of x squared plus y squared. So that's where this is coming from. Right? It's really just the hypotenuse. So from that, right, so say, then it follows that the 6 trig functions can be evaluated as follows. And I'll do this on the next page. But really, keep in mind what we had. All right, we had this right triangle, and I'll just draw a quick sketch of it here so I don't have to go back and forth to it. It's the x-axis, this is the y-axis. Alright, so here's the right triangle. Here's theta. This distance was x, this distance was y, this was r. And using trig functions, we know that the sine of theta is equal to opposite over hypotenuse. So sine of theta would be y over r, right? The opposite side over the hypotenuse. And cosine theta is equal to adjacent over hypotenuse, so it's going to be x over r. And this is the same way we did it with the unit circle when r was 1. Now the difference is that r could be any radius. And then remember, tangent theta is going to be opposite over adjacent, which would be y over x. You can also think of it as sine over cosine, and then the r's would cancel in the denominators. From these, you can get the other trig functions. Because remember, sine goes with cosecant theta, and that's going to be equal to just the reciprocal. So it's going to be equal to r over y, so you're just flipping it. Cosine theta goes with secant theta. Again, all we're doing is flipping it. It's r over x. And tangent goes with cotangent theta, which is equal to x over y, just taking the reciprocal of tangent. So those are the 6 trig functions. So if I give you a point x comma y, you should be able to find all the trig functions for the angle at that point. And that's what we're going to show in the examples next. Alright, so for example, given that the terminal side of an angle theta in standard position passes through the point -3, -4. Find the values of the 6 trig functions for theta. All right, and we'll talk about the solution down here. So it tells us the standard position of the angle passes through the point -3, -4. So if I was drawing this, just to have an idea what it looks like, remember it's telling you x is -3. And the y value would be -4. So the point they're talking about is right there, right -3, -4. And they're talking about the angle that goes through that point. So they're really talking about that being theta. Now realize I don't know what theta is, right? I don't know what the angle is. All I know is that it goes around and through that point. Right? But this creates a right triangle. If I look at this, this really creates a right triangle in the third quadrant. And I know that the length of this line, all right, is going to be 4, because the distance here is 4. And I know the length of this side is 3, because I know the distance here, going from 0 to -3, is 3. Now, you could use this as positive or -4 and -3 here if you wanted to show it that way. It really doesn't matter, because later on we'll talk about how the quadrant helps you know where you are. All right, so we know we're in quadrant 3, so that tells us that tangent and cotangent are positive. And we talked about this in class the other day. So we know the tangent and cotangent should be positive here for this angle. Everything else should be negative. And to find r, all right, to find this radius, to find the hypotenuse, really what I'm looking for, all I'm going to do is take the square root of x squared plus y squared, which really means r is equal to the square root of x squared would be negative 3 squared plus y squared is negative 4 squared. Make sure you got the parentheses around it. So we get r equals the square root of 9 plus 16, which equals the square root of 25. So r equals 5. And I'll continue this on to the next page. So we know r equals 5. And we know we got the point negative 3, negative 4. Remember, this is x and y. So if I'm drawing the triangle that goes with it, we saw it on the previous page here. R is equal to 5 here. So we have a triangle that's got sides 3, 4, 5, and theta is the angle that's right here. So to look for the 6 trig functions, I'm looking for the sine theta. All right, it's going to be negative, all right, because we're in quadrant 3. So we know it's going to be negative right away. You could also get that from knowing that the y value here is really a negative 4, right? This distance is down 4, so it's a negative 4. All right, so if I was looking at that, going back to here, I could say this is going to be negative 4 over 5, right? It's y over x. The way I like to think about it, though, is that this is my reference angle, this angle in here. So I know I'm going to be looking at this as, in terms of sine, as opposite over hypotenuse. I think it's easier to think about than just thinking about which quadrant you're in. You can actually look at it saying, okay, this angle here is the reference angle. It's measured from the x-axis, remember. So opposite over hypotenuse is 4 over 5, rather than thinking about it in terms of y over r. All right, cosine theta would be equal to, this is adjacent to this angle over hypotenuse, will be negative 3. All right, so that distance is negative 3 over 5. And cosine should be negative because we're in quadrant 3. Tangent theta should be equivalent to the opposite over adjacent. So we're looking at negative 4 over negative 3. Remember, tangent is supposed to be positive, so if I'm looking at negative 4 over negative 3, it's really going to be, right, I can write it this way, negative 4 over negative 3, but it's going to equal 4/3. Now to find the other trig functions, you're just going to take the reciprocal. So cosecant of theta is equal to, if I have negative 4/5, the reciprocal, that would be negative 5/4. Remember, cosecant goes with sine. Secant of theta, right, is equal to, remember, taking the reciprocal of cosine is negative 5 over 3. And cotangent theta is equal to, taking the reciprocal of tangent, 3 over 4. And notice these two should be positive because we're in quadrant 3. And then you have it. All right, you should try the next example on your own. So I'm going to write it out, and then I would recommend pausing the video, trying it on your own, and then coming back and making sure you did it correctly. All right, so here's the next example. All right, given the terminal side, of an angle theta, passes through the point 15, negative 8. Find the values of all 6 trig functions. For theta. Alright, so I'd recommend pausing it now, trying this out on your own, and then coming back and watching the video example. Alright, so first for the solution. The point 15, negative 8. Let's take a look at where that is on the graph. Now, you don't have to be 100% accurate with this. We should have an idea. X is 15. Alright, Y is negative 8. So we know that the angle comes to here. So when I say the terminal side, remember you measure these counterclockwise. So that's theta. Alright, and this is going to create a triangle for us, right? It's going to be a right triangle, just like we had before. And if I draw the right triangle here, alright, we got the right triangle. Make sure you see that's 15. So this side here, let me just erase the 15 so you know where it is. 15 is the x value, right? It's the x value. So we know that the length of this side here is going to be 8, or if you want to call it negative 8, you know the length of this side here is going to be 15 because that's the x value, right? And we're looking for r. Notice we're in quadrant 4. So in that quadrant we know that cosine and secant are positive. Right? Everything else should be negative. The reference angle we're looking at for theta is this angle right here. Remember, you're measuring from the x-axis. So that's the reference angle right there. Right? You should be looking at that in terms of when we talk about opposite and adjacents. Right? So that's really the reference angle. And we got to solve for r because we want the hypotenuse. So r is equal to, remember, x squared plus y squared. So r is equal to the square root of, what else is going to be, x is 15 squared plus y is negative 8 squared. It really doesn't matter if you use the negatives here because they're going to cancel out anyways after they're squared. This is the square root of 225 plus 64. So r equals the square root of 289, which tells us r equals 17. I don't stop here, that's just finding the radius. Alright, so r is equal to 17. And now we can find the 6 trig functions. I'll do it on the next page just so I have more space. So starting with sine of theta. We know it should be negative because we're in quadrant 4 and sine is negative in quadrant 4. So you know it's going to be negative. We also can get it from the evaluation. Remember, we're using this as our reference angle because it's measured from the x-axis. And sine is going to be opposite over hypotenuse, so it should be negative 8 over 17, which makes it negative 8 17ths. Cosine theta. Alright, cosine, remember, is adjacent over hypotenuse. Remember, a reference angle is measured from the x-axis. So adjacent would be 15 over hypotenuse is 17. Notice it's positive, which it should be because we're in quadrant 4. Cosine is positive there. So it's going to be 15 over 17. And tangent theta, remember, is opposite over adjacent, or you can think of it as sine over cosine. But from our reference angle, the opposite is going to be the negative 8 over the adjacent is 15, so it'll be negative 8 15ths. Remember, it should be negative because we're in quadrant 4. Alright, once you have those, you can find the ones that go with them. So cosecant theta, remember that goes with sine, is just taking the reciprocal. So it's going to be a negative 17 eighths. Secant theta, taking the reciprocal here, is 17 over 15. And notice it's still positive because we're in quadrant 4. And cotangent theta is equal to the reciprocal of tangent, so it should be negative 15 eighths. Alright, so it's important to know the reciprocal identities. In other words, which values go with which. I'm going to write them out so you have them, but really we've been using them all along. Alright, so these are the reciprocal identities. And all I'm saying here is that sine theta is equal to 1 over cosecant theta. And the opposite of that would be cosecant theta is equal to 1 over sine theta. If it's a fraction already, though, you just flip the fraction. Because 1 divided by a fraction, you'd be multiplying by the reciprocal. Cosine theta is equal to 1 over the secant of theta, which is the same here. Secant theta is equal to 1 over cosine theta. So cosine and secant go together, sine and cosecant go together. And then tangent theta is equal to 1 over cotangent theta. And cotangent theta is equal to 1 over tangent theta. Right, just so you know what goes with which. Once you have these, you know, it's fairly straightforward to find the opposite one. You just do 1 over, right? Or take the reciprocal. That's really what it means. All right, so just take a couple examples with this. So if I said A, find secant of theta given that cosine theta equals 5/8. Well, for our solution here, based on those identities, cosine goes with secant, right? Secant theta is really equal to 1 over cosine theta. So really it's going to be equal to, all you got to do is flip it. I mean, you can look at it as 1 over 5/8, but multiplying by the reciprocal really just means that it's going to be 8/5, and that'd be the answer. You don't necessarily have to show this step here. We do the 1 over 5/8. If it's a fraction, it's 1 over cosine, you just flip it, and you get 8/5. Right, should be fairly straightforward. Part B. If I said to find sine theta, given that cosecant theta equals √2. Well, for our solution, right, we know that sine goes with cosecant, so sine theta is equal to 1 over the cosecant theta, which really is just 1 over whatever we have here. So 1 over cosecant theta is √2, so it's 1 over √2. And you could leave it like that. I wouldn't be bothered by it. But if you do rationalize it, and times √2 and times √2 to rationalize it, becomes √2 over 2. Which, either of these is okay. Generally, you're going to see it in the √2 over 2 form more often when you check in your textbooks. Alright, so we know here that sine of theta is equal to square root of 2 over 2. It also tells you that the reference angle for that is pi over 4, or 45 degrees. Remembering that the sine of 45 degrees, or sine of pi over 4, is equal to √2 over 2. It's positive, so you know it has to be in quadrant 1 or quadrant 2, but we don't know which. That's all the information we know. So we know theta is an angle in quadrant 1 or quadrant 2 with a reference angle of 45 degrees. So it's 45 degrees or 135. Or in radians, pi over 4 or 3 pi over 4. Just to give you some information there. Because we're going to be using this in a minute. Alright, taking a look at the quadrants again, just so you remember. Alright, so just quickly recall. Alright, for our trig functions. Alright, in quadrant 1, all trig functions are positive. In quadrant 2, it's just going to be sine and the one that goes with sine, which is cosecant, are positive. Everything else is negative there. In quadrant 3, it's tangent and cotangent that are positive. Everything else is negative there. And in quadrant 4, where it's cosine and the one that goes with cosine is secant, are positive. Everything else is negative there. And remember, I said one way to remember it might be all students take calculus. Whichever way you remember it, though, is make sure you know where each trig function is positive. Alright, we're going to use this to help us figure out where certain angles lie without actually knowing the angle. Alright, so in these examples, we want to identify the quadrant or quadrants of an angle that satisfies the given conditions. Alright, and the first one. We got cosine theta is less than 0 and sine theta is less than 0. Now if I have cosine theta is less than 0 and sine theta is less than 0, let's talk about which each of these means. All right, first off, theta is the same angle on both of them, so it has both these properties. So cosine theta less than 0, what that really tells me is that I'm either in quadrant 2 or quadrant 3, because cosine is negative in quadrants 2 and 3. It's positive in quadrant 1, and it's positive in quadrant 4. Alright, because quadrant 1 they're all positive, in quadrant 4 only cosine is positive, or cosine and secant are positive. So cosine being less than 0 tells you cosine is negative, so that tells you that you're either in quadrant 2 or quadrant 3. Sine being less than 0, that tells you that you're either in quadrant 3 or quadrant 4, because sine is negative in quadrant 3 and quadrant 4. It's positive in quadrants 1 and quadrants 2. So if cosine theta is less than 0 and sine of theta is less than 0, it has both of these, then you need what's common to both of these. And the only place that both happens is quadrant 3. So theta is in quadrant 3. Because that's the only time that both conditions are satisfied. Remember, theta is the same angle in both of these. So we know theta is in quadrant 3. Let's take a look at another one. If I said cosecant of theta is greater than 0 and cotangent of theta is greater than 0, so it has to meet both these properties. Alright, well, for cosecant theta being greater than 0, cosecant, remember, goes with sine. So this happens in either quadrant 1, where they're all positive, or quadrant 2, where sine is also positive. Right, because that means cosecant is positive. Cotangent theta greater than 0, well, that's positive, so in quadrant 1 they're all positive there, and then cotangent is positive in the same place tangent is, which is quadrant 3. So the only one that's common to both lists is quadrant 1. So theta is in quadrant 1. Alright, so the angle theta is in the first quadrant is what that tells us. It doesn't tell us what the angle is, but we know it's got to be in quadrant 1. Alright, let's take a look at another one. If I had cosine theta is greater than 0 and secant theta is greater than 0. Cosine theta is greater than 0, well, that's either in quadrant 1 where they're all positive, or cosine is also positive quadrant 4. Secant theta greater than 0, well, secant goes with cosine. Well, cosine is positive in quadrant 1 where they're all positive, or in quadrant 4 where cosine is positive. So here, you can't get a conclusive answer. So 1 and 4 are both common to both lists, so quadrant 1 or quadrant 4. Alright, we don't know which it is. We know theta's got to be in one of those two quadrants, but we don't know which one it is. Alright, and taking a look at another one. Let's talk about the sine of theta is greater than 0 and the tangent of theta is less than 0. The sine theta greater than 0 tells me I'm in quadrant either 1 where they're all positive or quadrant 2. Tangent theta being less than 0 tells me tangent is negative. That only happens in quadrants 2 and quadrants 4, because tangent is positive in the first quadrant or in quadrant 3. So the only one common to both lists is quadrant 2. Alright, so theta would be in quadrant 2 here. Alright, so we can use information about the angles to figure out which quadrant it lies in. The next thing to look at is some Pythagorean identities. And we've talked about these already. We're just going to state them again so you see them. Alright, so Pythagorean Identities, where the first one was sine squared theta plus cosine squared theta equals 1. It's probably the most important one to know. 1 plus tangent squared theta equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. And we talked about these already and realized that, you know, to get from the first one, which is one you should really memorize the most, to the second one, all you would really do is divide the whole thing by cosine squared in each term. That would simplify to 1 plus tangent squared over secant squared. Or if you want to simplify to get the second one, you would divide sine squared plus cosine squared equals 1. You could divide that all by sine squared theta, and then that would give you the second identity. And we talked about this in class, so I'm not going to spend a lot of time here on it. Also, don't forget that tangent theta is equal to sine theta over cosine theta. That's a pretty important one to remember, because if you're given sine and cosine, you can find tangent, and then from there you can find all the other trig functions. So we can use these identities along with information about quadrants to figure out all the trig functions for a certain angle if I give you one of them. Alright, so all you need is one trig function for an angle, and you can find all the others for it. And that's what we're going to do next. Alright, so for example, if I said find all trig functions for each angle theta given. Right, and the first one we'll look at here is if I said tangent theta was equal to 3 over 4, I'll say given that theta is in quadrant 3. Alright, so for a solution, first thing to note is just because tangent is equal to sine over cosine doesn't mean you can say sine equals 3 and cosine equals 4. We actually know that's wrong automatically because sine and cosine have to be between -1 and 1. Remember we talked about this the other day in class. The range for sine and cosine can only range from -1 to 1. So you can't just say sine equals 3 and cosine equals 4 because you know tangent is equal to sine over cosine, because it could have been reducing that went on in there. Here's what we know though. Alright, we know that we're in quadrant 3. Alright, and since we're in quadrant 3, that tells us that, you know, sine and cosine are both negative, because tangent's positive in quadrant 3, sine and cosine are both negative there. So that's one thing we know. From there, I would draw a right triangle. Alright, and I would use right triangle trig to help me out here. So if I draw a right triangle here, and here's my angle theta. Alright, we know that tangent theta is equal to 3 over 4. We can write that in here. Tangent theta, remember, is opposite over adjacent. So the side opposite theta I would call 3. Right, the side adjacent theta I call 4. And now I can find the hypotenuse using Pythagorean theorem. Right, so I'm just using Pythagorean theorem here and saying that a squared plus b squared equals c squared, and I'm trying to solve for really c, the hypotenuse. Well, a squared we can say is 3 squared plus b squared is 4 squared equals c squared. 3 squared is 9 plus 4 squared is 16 equals c squared. So c squared equals 25. So c is going to equal 5, taking the square root of each side. Alright, so we know this is 5. And now to find the trig functions, all I'm really going to do is use my information from the triangle and that I'm in quadrant 3. It tells me sine and cosine are both negative. So now I'm going to fill in the information for the trig functions. And this is probably the most important part of this section, is knowing how to do this. So for the sine of theta, first thing we know, we're in quadrant 3. In quadrant 3, sine is negative, so we're going to start by putting a negative down. And now we don't have to worry about the sign anymore. We know it's negative. And now I'm just going to use my triangle that I drew here. I want to do opposite over hypotenuse. The opposite is 3 over the hypotenuse is 5, so the sine of theta is negative 3/5. Alright, cosine theta, we're playing the same game. Which quadrant are we in? We're in quadrant 3. Quadrant 3 tells us that cosine is negative. So we know it's going to be negative, we don't have to worry about anything else. Alright, once that's negative, now I just use cosine is equal to the adjacent over hypotenuse. So it's 4 over 5, so this is a negative 4/5. Tangent theta, alright, which I already gave you, is equal to 3 over 4. You know this from the problem itself. That should be easy points. You also can just look at the triangle you have drawn, right? Opposite over adjacent is 3 over 4. From there, you can find the remaining trig functions, right? I know cosecant theta is really just taking the reciprocal of sine theta, so it's going to be negative 5/3. I know secant theta is just a reciprocal of cosine, so it's a negative 5/4. And cotangent theta is equal to reciprocal of tangent, so it's 4/3. And then you've answered the question. Right? It's probably the easiest way to do it is using right triangles based on the trig function you're given, and then the quadrant the angle is in. The quadrant the angle is in tells you the sine, S-I-G-N sign of each. All right? And the angle you're given helps you use Pythagorean theorem to find the other side of the triangle you need. All right? I would recommend trying this next example on your own, and then pausing the video, coming back to it, and then checking to see if your solution is correct. All right, so here's the next example. So B, if I said given the sine of theta is equal to the square root of 2 over 6, and theta is in quadrant 2. Alright, so we're going to look for all 6 trig functions. Alright, so I'd pause it now, try this on your own, then come back to it and look see if you did it correct. Here's a solution. Alright, so first thing we know, we're in quadrant 2. Being in quadrant 2 tells you that, sine is going to be positive, cosine and tangent are going to be negative. Alright, so that helps you when you go to find the trig functions, because you know the sine, SIGN signs on them right away. And knowing that sine theta is equal to root 2 over 6, I'm going to fill out a right triangle. Here's theta. Sine of theta, remember, is opposite over hypotenuse, so the opposite of theta is root 2. The hypotenuse here would be 6, right? Opposite over hypotenuse. And we're trying to solve for this side down here. Let's call it x for now. And we're going to use Pythagorean theorem. So we got x squared plus square root of 2 squared equals 6 squared. Alright, so remember this is a right triangle here. So the side opposite the right angle is the hypotenuse. It's got to be by itself. So x squared plus square root of 2 squared is just 2. Equals 6 squared is 36. And solving this, we're going to subtract 2 from each side. Subtract 2. We get x squared equals 34. So x equals the square root of 34, which is the same as saying 2, or square root of 2 times square root of 17, but it's not, does not have a perfect square factor, so you don't have to worry about it. So yeah, I have x equals the square root of 34. Alright, so that's this side down here. That's really my adjacent side. Now we can go through and find all the trig functions. I might do this on the next page just so I have more space. I'll redraw the triangle though. Alright, so here's the triangle. I'm going to redraw the triangle here for us. Alright, so there's a right angle. This side square root of 34. This side was square root of 2. This side is 6. Alright, and theta was down here. I know this isn't to scale, but that's okay. So we know we're in quadrant 2. Let me write that a little better. Alright, so we know that we're in quadrant 2. And that tells us that only sine and cosecant are positive. Right? Everything else should be negative. So looking at this, the sine of theta is equal to opposite over hypotenuse, which is root 2 over 6. It's positive because we're in quadrant 2. And we knew that because that's what they gave us at the beginning of the problem. Cosine theta is equal to, from here we want to do adjacent over hypotenuse. Now we know we're in quadrant 2. So in quadrant 2, cosine is negative. And then the adjacent is square root of 34 over 6. Okay, we can leave that just like that. The tangent of theta, again, we're in quadrant 2. Tangent is negative in quadrant 2. And then tangent is the opposite. Alright, so opposite of theta is root 2 over the adjacent, which is square root of 34. And you can rationalize this a bit. This is equal to a negative. If you multiply both numerator and denominator by square root of 34, to rationalize the denominator, you get negative root 2 times 34 is really a radical 68 over, in the bottom, square root of 34 times square root of 34 is just going to be 34. So you get negative root 68 over 34. Well, that's equal to a negative. This is really the square root of 4 times the square root of 17 over 34. Just finding a perfect square factor, 68. Which really makes this negative 2 square root 17 over 34, which if you reduce this gives you negative root 17 over 17. So the tangent of theta is equal to a negative square root of 17 over 17. Alright, so we got sine, cosine, and tangent. Once you have those, to find the remaining ones, fairly straightforward. Cosecant theta goes along with sine theta. So right away we know that's 6 over square root of 2, just taking the reciprocal. If you wanted to rationalize it, you can. Multiply by root 2, multiply by root 2. This ends up being 6 root 2 over square root of 2 times square root of 2 is just 2. And this reduces to 3 root 2. Just 3 root 2. Sorry, not root 2. This reduces to 3 root 2. Right? 6 divided by 2 just gives you the 3 in front. Alright, so that's cosecant of theta. Cosine goes along with secant, so secant theta is equal to negative, still negative, and the reciprocal is 6 over square root of 34. To multiply by square root of 34, to rationalize it, is equal to a negative 6 root 34 over 34. Reducing these by 2, you get 3 over 17. So secant theta is equal to negative 3 root 34 over 17. And then for cotangent theta, get that by taking the reciprocal of tangent, so this will be a negative 17 over root 17. If you rationalize this, multiply by root 17, both the numerator and denominator, it's going to be equal to a negative 17 root 17 over 17. And the 17s are going to cancel, so you're left with negative square root of 17. And that's cotangent theta. Alright, so then we got them all. Alright, I would recommend that you practice the homework for this section. Alright, so I would say do the homework for section 8.5 on the yellow sheet. Remember, you'll have a quiz like one of those last two, a question on your quiz like one of those last two that we just completed. So make sure you practice that for the in-class quiz on Tuesday.